So I just have to share this. I spent, I think, 3 hours last week debugging this internal automation script.
Oh, no.
Yeah, and the model just kept getting stuck. It understood all the individual steps,
Yeah.
but it had no judgment. It couldn't handle the edge cases.
Hand-holding problem.
Exactly. I just kept thinking, we need an AI that can actually orchestrate a complex job from start to finish.
Well, that friction point you're describing is exactly what we're diving into today. Anthropic just released Claude Opus 4.5 and a whole new suite of developer tools.
And they're framing this as a pretty big deal.
A huge deal. They're positioning it as the new state-of-the-art for coding, for agents, for using a computer, and it seems to be meaningfully better at things like deep research, even working with slides and spreadsheets.
I saw one stat that, it just blew my mind.
The engineering tests.
Yes. They gave Opus 4.5, this notoriously difficult 2-hour internal software engineering exam. And using some parallel compute, it scored higher than any human candidate ever.
It's an unbelievable benchmark. And really, it's not just the raw score, it's the efficiency behind it.
Right, the pricing.
Exactly. They slashed the token prices down to $5 and $25 per million tokens. And they've made these huge efficiency gains, cutting token usage basically in half while still hitting those top-tier coding benchmarks.
Okay, let's talk about that deeper intelligence, because raw performance is one thing, but ambiguity, that's the real test.
That's where it really shines. It's this ability to reason about trade-offs, the classic airline agent problem.
Where you can't modify a basic economy ticket.
Right. The policy says no. But Opus 4.5 found this legitimate workaround. It realized you can upgrade the cabin first, and once you do that, then you're allowed to modify the flights.
Wow. So it's not breaking the rules, it's finding a new, valid path through the rules.
It reasons its way to a solution. That's the leap.
But does that kind of creativity, create new safety risks if it's finding paths we didn't intend?
That's a critical question, and they seem to have focused on it. They're saying there's substantial progress in safety, especially against things like prompt injection attacks.
Making it harder to trick.
Harder than any other frontier model out there, apparently. And they've also given developers a new level of control. There's this new effort parameter in the API.
So you can kind of dial it in.
Precisely. You can tell it to either minimize time and spend or go all out and maximize capability. For example, at a medium effort, it can match Sonnet 4.5's best score while using 76% fewer tokens. You get to control that cost-performance ratio.
Okay, so let's unpack the tooling needed for this. Because with more intelligence, you need better ways to interact. For these complex agents, the biggest problem is just context bloat, isn't it?
Oh, absolutely. Imagine trying to give an agent thousands of tools. You could eat up 100,000 tokens just in definitions before it even starts the task.
It's like handing someone a 100-page manual for a job they haven't even started.
Which is why they built the new tool search tool. Instead of loading everything up front, which is so inefficient, the model just discovers tools on demand. Think of it like lazy loading.
And that saves a lot of tokens.
It reduces token consumption by an incredible 85%. It just preserves the context for what actually matters and makes it way more accurate with large tool libraries.
Okay, so that's finding the tool. What about using it? If you're running a budget check and it pulls back like 2,000 line items of expenses?
Yeah, you can't just stuff that raw data back into the context window. It pollutes everything.
It's slow, it's expensive.
That's where programmatic tool calling, or PTC, comes in. Claude basically writes a little Python script to handle that heavy lifting in a sandboxed environment.
So it delegates the busy work.
Yes. Claude only sees the final concise result, like a 1 kilobyte summary, not the massive raw data. It just eliminates that context pollution completely.
Got it. So intelligent search, efficient execution. The last piece is just getting the formatting right? Schemas are good, but they don't always capture, say, a specific date format.
And that's solved by tool use examples. You just provide a few concrete successful samples along with the schema. In their testing, that alone improved accuracy on complex parameters from 72% up to 90%.
So the whole package is there. Deep intelligence, smart tool search, code orchestration, and better accuracy. This really does feel like it makes powerful agents a reality.
It's the full stack.
And if you're listening and thinking about where agents could make an impact for your business, whether for AI training, automation, or software development, this is a good moment to thank our sponsor.
God.
Check out embersilk.com. They can help you identify exactly where this kind of powerful agent orchestration can really transform your workflows.
To really connect the dots for you, we are seeing a shift here. Agents are moving way beyond simple function calling. We're talking about intelligent, long-horizon orchestration that can solve really complex problems.
And it seems like the progress itself is accelerating. I saw they found these agents can autonomously refine their own abilities.
That's maybe the most exciting part. In office automation tests, an agent achieved its peak performance in just 4 iterations.
It improves itself.
It improves itself. It shows a clear path toward continuously optimized systems. I mean, it's a hugely optimistic time for the future of work.
The future looks fast.
It certainly does.
If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.